Hello, I was not aware of this workshop. I got an email from Jose. Not coming, what is this? I learned about it a few hours ago. So, hello, Jose is asking me to introduce our faculty member, Dr. Carlos Paternina. He's been here for
3.5 years.
3.5 years, and before that, you were a full professor in your country, and there were
for 20
years. Plus years. So he has a lot of experience in the industry, and also his research is heavily driven by the actual need, what the industry needs. So he has a very in-depth understanding about his area of expertise, which is supply chain management. And he applies very technical approaches to solve the problems of this supply chain management. And today, we're talking about AI. Everybody's talking about AI. So he's using AI to solve some of the problems that with ports in different cities are facing. So thank you. Thank you, Carlos.
Thank you, Vanshik. And Vanshik Singh is the chair of the Management Information Systems Department, which is where I am also hosted. Thank you, Jose, for inviting us to be part of the colloquium again. This is the second time I come, actually, to present part of what I do. Actually, I was expecting to see my student, which is a computational science student here, because she is working with me in this project. So I'll talk to her. So what I'm going to present to you is a grant that I just started last week, actually, and I'm going to be developing a system for a company that we're collaborating with called Wabtec Corporation. They used to be General Electric Transportation Division. We should have started about 4 months ago. It took us 6 months then contracting negotiations. IP was the deal. Intellectual property between the university was going back and forth with the sponsor. So right now we're in a point in which we can move on, and the basic project is called AI-driven emissions optimization at the Port of LA. Interesting enough, we're not going to be working solely at the port. We're going to be working, and I'm going to explain. There may be some of the students that are here could relate to what I'm going to do in the environmental side of it. But I'm going to explain why we are moving forward to the hinterland of the port. The hinterland is the area that actually has stakeholders related to activities that the port do. So transportation companies, warehouses, and even the regulatory systems that we work with, we're bounded by. This is a joint work, and I want you to please understand sustainable as the point in which we cross the 3 areas of sustainability. It's not just environmental. We're trying to be to deliver a solution which is oriented towards efficiency, which will tackle the economic prosperity of the system, a solution that tackles reduction in emissions, which will be moving towards planet, and then somehow part of not really what we're going to do in large in this project, but part of what we can hold to be equitable and socially, let's say socially oriented, not equitable, socially oriented. So, move on.
Try clicking the key. No?
It's locked.
Oh, yeah, okay.
Move them up. Yeah, let me try. Yeah.
Okay.
So the main deal here is we're going to try to build what we call a carbon intensity gateway. That was the original name. However, when we started discussions with the port, then other emission types, not only those related to carbon, were put into the table. And then methane emissions, and then hydrocarbons, and what's the other one? SO2, sulfurs. They were brought to us in terms of we need to control this. We need to have a compound metric that helps us understand how we are contaminating somehow, or how either directly or indirectly. So this is a collaborative project with Wabtec Corporation, as I told you, and it's for the Port of LA. The project is funded by the GOVIS program from the state of California, and the system should be embedded within an already platform that they have in the Port of LA called Port Optimizer. Port Optimizer is a port community system, and this is something that I have been working for a while now. I think my publications in the field come from 2018, sorry, and a development of a similar solution was deployed in the port of Cartagena in Colombia by my team. So the challenge is the Port of LA is a major gateway for global business, global trade, but it's also a significant source of emissions. And emissions come from different fronts. Yes, they're being trying to move into cleaner, more hydrogen-powered trucks and more electrical equipment, but then there's a balance between cleaner and autonomy of use. So the energy, the power that they use actually drains out more easily than when you have a diesel-powered machine. So that's one thing that we need to understand. The other point is that the vessels, actually, you can regulate the type of fuel that a vessel is using once it enters your area of comfort or your area of incidence, which is right when you're piloting the vessels to the harbor. But you cannot control what happens before that. So our first stage, which is the part that we're starting now, will deal with whatever is under the Port of LA control. So we cannot put there, although we have the information, and I'm going to tell you where the data feeds come from, although we have the information of what fuel type, what boiler, what everything that the vessels are using, based on their AIS system, which is the automated identification system for the vessel, we can only integrate into whatever we do, only what happens within the boundaries of the port. So only the blue zone of the Port of LA, in the Bay of San Pedro. Then there's a lot of regulatory pressure and environmental concerns that are driving this, especially because we're in California. I mean, should we be in South Carolina or in Texas, where we do have the two most efficient ports in the country right now, then the emissions would not be that big of a problem. But here in California, it is a very, very big deal. So we need to abide by the law in that sense. So what it means and why it is important and why this is a challenge for them is that if a port exceeds the threshold of emissions, then the port has to halt operations. If they halt operations, just 1 hour is exceeding $1 billion of profit not made. And then everybody would tell me, yeah, but then the environment would be safe. And you know what? There are ways that we can manage the scheduling of the vessel, loading, unloading, the use of quay cranes, the use of equipment, all of the resources in the port, while we also balance the emissions that we're given. By the way, we're only dealing right now with air emissions. So air quality is the main concern in this project. The future stages will deal with effluents to the marine layer and with other noise pollution as well. The third part is that, yes, we can solve this problem. And we have been doing the technical part of it for a while. So since I told you, I've been working in port community systems since 2018. I've been working in prediction of emissions for ports since 2021. I've been working in optimizations ever since I graduated from my PhD program. And as Bonshi was telling you, most of my work is directly applied to industry. So this is something that we have done in different setups, routing, vehicle routing, long-haul routing. Those are things that we have worked on before and which are going to be part of what we will develop here. Why it matters? There are environmental and economic impacts on this. So maritime and intermodal emissions contribute significantly to air pollution and GHG emissions, and there's no doubt about it. The Port of Hamburg calculated that 27% of the emissions of the city are related to emissions that come from the port operations. 27% of those emissions. So if we can tackle down with a port like the Port of LA, yes, LA is a large city, but if we can tackle down the emissions that the port can make, or can produce, then we can significantly also reduce the impact towards the city. And you know that whatever comes into the city, then there's a whole different issue that we need to manage. The main regulation that we're under scoring here is the Clean Air Action Plan, but we also have EPA regulations. We have California bills that have to be taken into consideration. And then why it matters also is because optimizing emission benefits port operations, the supply chain, and the local communities. So you give less emissions, then the social issue of sustainability is also being taken care of.
Los Angeles has one port,
Look,
but Long Beach is basically Versailles.
yeah, I'll go there. I'm going to go there right away. The GoBees program actually gave, it was $45 million altogether for all the ports that were part of the GoBees structure. The Port of Long Beach was given $7 million. The Port of LA was given $8 million. They don't really talk that much between each other. They don't actually work many things together, except when they are forced by the state to work together. This is one of the times that they have to work together. However, the pilot is on LA. So whatever we do here, they have to extend to the other ports in California, which is from Oakland, Guanimi, San Francisco, all the ports basically that we get. But yeah, it's clear that the Bay of San Pedro has the two main ports of the West Coast, which are Los Angeles and Long Beach. The two together move almost 2 million containers, TEU containers per month. And that's really one of the largest movements of containers in the world. Okay. Sadly, the Port of LA and the Port of Long Beach rank 200 plus in the ranking for container port efficiency. I mentioned before that in the world, I mentioned before that the two more efficient ports are Houston and the South Carolina port, mainly because of automation and the use of technologies. We have a lot of restrictions here for the use of automation. However, LA just started. The APM terminal is now fully automated. And that deals with a lot of different things, especially in the people's side of it. So there are other considerations that had to be put into account here. One is that for every 8 containers that you bring into a port, you give one more job. So when you automate, that 8 goes to 16. So you need to bring 16 more containers to give another one job to the market. But it's still a good deal. So if you make it more efficient, more cargo will come. Many of the cargo that we lost it to Houston. And the line of indifference actually was larger. And line of indifference is the line at which in the United States in which it's better to go through the Panama Canal rather than go through land freight or road freight from the Port of LA. So what happened is Houston is more efficient. And now there are many people that are in the center of the United States and farther are preferring to go to Houston just because the efficiency there is giving them more profitability. Okay. All right, so just to end the scoping of the project, I didn't use on purpose the term scope, but we have 3 types of scopes of emission that we deal with. Direct emissions, which are the ones that the port actually can control itself. That means the equipment that the port actually uses, the cranes, the yard management systems, all of the equipment that is within the port and is under the control of the port, that's considered to be Scope 1 emissions. Scope 2 is the electricity that we buy. Okay, so those are indirect costs that come, environmental costs that come to the equation. But still, you can buy from sustainable sources. So you can balance that. Somehow it's still more expensive, to buy from sustainable sources, but that's coming to a balance right now. And Scope 3 are the emissions of others. That means I don't buy them. I don't buy those emissions. I don't control the emissions. That's the emissions from the trucks. That's the emissions from the vessels. That's the emissions from the warehouses that I have to use externally to the port just because they help me in my operations. And to be honest, we're only considering until the first point of destination. as for emissions, what it matters for emission. But the eco score that we will give to each container will be considered or calculated based on the optimization in the network that we do until the last point of destination. Okay, so we can actually measure or emulate or calculate what would be the eco score of any given container based on how we route it in the system and what type of equipment is using. Are we going to be using diesel powered equipment or electric powered equipment or hydrogen powered equipment? Are we going to the railroad? And if we are in the railroad, then are we using, again, diesel powered trains? Are we using electric trains, or are we using any other powertrain? So that's for the different scopes in emissions. This is, again, everything that's port direct, fleet vehicles, buildings, stationary sources. This is the electricity that is purchased. And this is everything else that we don't control. We can measure it, and we can have an incidence in what happens, but we don't control it. Okay, at the end is the shipper who decides, yes, I'm going to use your suggestion of bringing it to a waterway so that it could cost us less. It could cost less to the environment. And when I say cost to the environment, it's a total generalized cost from the transportation engineering point of view. So our approach is we're developing. Originally, it was a carbon emission model to capture emissions from vessels, trucks, rail, and port equipment. We're going to use real-time and historical data for predictive and prescriptive modeling. So historical data will help us to predict. Real-time data will help us to foresee what can happen, plan scenarios, and then try to anticipate what could happen with the optimization systems that we are integrating. And then at the very end, we are an information systems department, so there has to be an information system, right? So we're integrating this with the port community system that they have already in place. That means that whatever we develop has to handshake with their system. I have to bring the data, transform the data, find the features which are important, then with those features predict or prescribe, and then whatever we do there, we then send to the optimization model so that we can route the container more efficiently and more environmentally friendly. Okay. And then we send back that information to the port community system. Now, the technical side of it, because it matters. It matters to be more conscious. It matters to be efficient. It matters to be in that center in which we are socially responsible, environmentally conscious, and profitable. Now, how we do it is the set of tools that we're integrating to work on this. The first part of it is that we need to work on the data part, the data side of it. So we have to, we have to set up a systems boundary definition. We have to set up what data feeds are we going to work with, which are more relevant to the measures that we need to intertwine. Then we are feeding that data already pre-processed to our machine learning models. And we have been using basically 4 different types of tools. We're exploring with a 5th one right now. But we have made comparisons between different types of deep neural networks. We have used recurrent networks. We have used least squares modeling. We have used AutoML TPOP tools too. So, and now we're introducing Kolmogorov-Arnold networks to evaluate the feasibility of how these mathematically based neural networks, deep neural networks, can work for us into predicting or prescribing in the models. Yes.
What was the name of that model? I'm never hearing.
The last one?
Yeah, the last.
Kolmogorov-Arnold.
What is it?
Kolmogorov-Arnold networks.
Okay.
It's called CAN.
Oh, it starts with a K.
Yeah.
Oh, okay.
Yeah.
Now I know.
Like the Kolmogorov-Smirnov equations in dynamic optimization. Well, the first part of it.
Yeah.
Yeah. The K, the Kolmogorov, and it's basically for short CAN networks. So that's the main. See I have to deploy this for a company, so I have to use what I already used before. I have to make it quick, right? But the CAN network is a new methodology that is coming to place that is very interesting to evaluate. So my students are going to be working with it. That's the research part of it. Okay. And yes,
I'm sorry, I have a quick question. So you're using neural networks mainly. This system should be in real time, or that's fine to have some latency?
so the networks will help me predict,
Yes.
but whenever you're in real time, so this is the fun part of it. And what I've done before, which has worked, is I have used the neural network to learn and then dump it into a decision tree type of thing.
Okay.
And then that decision tree can actually give you decisions in real time.
Okay, you are using ensemble.
Yeah.
Machinery. Okay. Thanks.
You have to make it usable
Yes,
somehow,
because of the-
otherwise it's going to be. Now the beauty of CAN networks is that it's mathematics.
Yes.
So at the end, what we're going to have is an equation. You have inputs, you have equation, you have outputs. So that could also be used in real time, but they have to be trained first.
Yes, that's good.
Then the next portion of it is using optimization models. In my case, it's mathematical programming. But we can also explore, because it's routing and it's a combinatorial problem, basically, we can also explore, and this is what I did for my dissertation when I was, that was 25 years ago already. We can use reinforcement learning methods and then feed a network model based on what we can do. We use approximate methods, again, for the real-time part. You have to sequentially adapt to making decisions on the fly. Yes.
So what are the time constraints though? I mean, it seems like it would be many seconds to many minutes and you could do forward pass through a large network.
Yeah. So for the simulation part, I have no limit. But for the reactive part,
Right.
I have to give a decision on whether a container has to be moved from one mode to another. That's called modal switching in transportation engineering. And that depends on whether that could be predicted. So time is not a constraint there, but that could be reactive if, for instance, you hit congestion, and then you have to decide rapidly how to move from one side to another.
But what does rapidly mean? I mean,
So
it seems
seconds,
like
basically,
seconds.
yeah, the decisions have to be made in terms of seconds. But yeah, to your point, you're completely right. I could all the predictive part of it, I can take whatever time I need. But once the container is on the run and it hits congestion, for instance, or let's say there's a huge storm of snowstorm in the east, and then now I have to think about my container is on the way. What do I do right now? Because if I overpass the previous link connection in the network, then I have to step back a little bit and then go in. So it's not computer networks, if that's your question.
Well, I'm just thinking, I mean, neural networks, once they're trained, you think of them as, even if they're very large, just doing a forward pass through them. It's not something that takes a great deal of time.
Yeah.
And the time scale, what you're trying to do, I mean, I'm kind of amazed that it's as short as seconds.
Yeah, it is, and I can show you some instances in which I need the seconds. But for some in the network, I mean, if I am just doing the simulation and calculating the equal scores, I can take even hours, and that's not a problem for a neural net, not at all. So to your point, it's only when you have to react that you have to do that. And by the way, reaction is very much needed within the premises of the port when you are assigning vessels to a berth, or when you are deciding on whether you have to get a vessel out of the berth or get a quay crane being sent to another berth, or the yard equipment to be used for another operation. So those kind of reactions have to be taken on the fly. Those are the ones that I'm more concerned with. Okay, because basically many of the sensors are IoT, so they're bringing you feeds all the time. It's all information. So based on that, on the cadency, on frequency of the information that we get from the feeds, then you make decisions there too. And it's basically within the premises where you get to be more reactive in that sense. Let me go back to the modeling to improve. I'm going to talk about that later. The funny part of this is that at the end, we have to integrate with Port Optimizer, which, by the way, doesn't optimize. That's the name that they gave it. Maybe that's the vision that they have for the future of the system. but that's the name that it's, and it's trademarked. It's interesting, but they don't do optimization so far. So we are going to start working with them in this. This is our first project, but we have a portfolio of projects with them that are going to go in the future too. So the first part of it is the data structure. And we have to worry about three main things. Who are we going to, and I'm going to start from the end side. Who is giving us the data? Some of the data is public. I mean, some of the data comes from the port itself. Wow. But some of the data comes from the vessels. All the information from the vessels, luckily, you can buy. You can actually, you pay $5,000 for all the data that comes for every single vessel that comes into a port. And that will be an annual fee. And there are many providers that can help you with that. And you can also find some open source data sources that you can use for that. Now, the quality of those open source data sources, that's something that has to be investigated for them. But we have shipping lines, and there are many of them. We have MTO systems. We have the truck TMS providers. This is transportation management systems. So if you are familiar with transportation, this is basically if you want to work with waterfront or with convoy. Well, convoy is no longer in the business, but with EF routing or with those freight brokerage platforms will tell you exactly where the truck is located, and it will tell you the motor standard, and it will tell you the acceleration, the velocity, all of the variables that you can get from an OBD2 modem from the computer of a truck. So once you get that information, you can transfer it to our system. And there are other sources like Marine Exchange for conditions on marine traffic, or truck ETL, rail link. This is from the railroads, the Port Authority from the Port of LA. All the emissions are going to come from them. And we found an air quality system from the state of California, which is deployed in Southern California, that we're also going to link to that. And it's public data, so that we can use freely. So these are the partners for the data sets or data feeds. And most of them are going to come with a frequency that is really, really, really frequent. Then what type of data we have is we have the vessels, estimated time of arrivals, all the electronic data interchange that we have with all the protocols, marine terminal destination, empty return quotas per MTO. So we're going to have many information for vessels. The vessels also need to understand the empty containers that are being returned, because that makes part of their business. They have to actually take those containers somewhere else to be loaded again. We have landside community that comes from the railroads, that comes from the trucks, that comes from the community itself. If you are one of these environmentally conscious persons, I am one of them. In that sense, you can buy air quality sensors and you can put them in your house if you want. And then once you connect, that's an IoT sensor. And basically, you are one more of that Southern California network, which is public. So you're giving feeds to the public system. That's part of what the community data comes from too. And then we have to take all the data feeds, transform them into what is actionable for us, what we can actually consider a feature to work with, okay? Like for instance, it would be interesting for me to know what's the amount of fuel being used when you enter the blue zone of the port until you're docked, and then since you're docked until you're served. And then that amount of fuel is of interest to me. The type of boiler that you're using is of interest to me. The size of the vessel is of interest to me. And I can tell you that because we have experimented with other data sets before, and it has become interesting for us in terms of what really represents the equations that we are finding, okay? Once you have those data feeds, then our methodology has been, and this is from the vessel side, and I have one of these for trucks, one of these for rails, one of these for the port equipment itself. And then when you are connected to, for instance, PortPro and then Waterfront, which are the port service providers, then they are going to give you their feeds as well. You get the data collection, you pre-process, you find relevant information, you clean the data. Okay, you get the type of vessel. You can have container vessels, you can have bulk vessels. You have the year. Well, by the way, this was really relevant in all the models that we have run so far. And it's like your car. If you have a 2005 car and you compare the levels of emission to a 2025 car, then probably our emissions in a 2025 car are going to be half than those of a 2005 car. Okay, so it would be similar here. So the year of construct is actually very important.
Which car?
Say it again.
Depends which car.
Well, the wear off is always
Still, but there is a lot of,
that's very low. Yeah.
that they have a loophole and they produce a lot of stuff, but they are.
Yeah. I can give you an idea. Many of the vessels are now mixing their diesel fuel, which is offshore diesel when they're offshore. They're mixing it with hydrogen. So they produce hydrogen, they make a mix, and then the mix produces a lot less emissions. And it's called HHO technology. Basically, you separate water via electrolysis or any other method, and then get the hydrogen. And your emissions on that, so the emissions on the diesel portion of it are still going to be the same, but because the mix is now using more hydrogen, then the total level of emissions is exceeding more in water vapor instead of the COs that are being emitted. Yes.
Yeah, how do you mix the hydrogen? Do you just inject it into the fuel and have it dissolve into the fuel mixture, or is that just?
That is out of my field of knowledge, but I can tell you that I have been researching this a little bit because of my father called me and told me, hey, there's this technology that I would like to. He has a Buick Regal, 1997, and he wants to convert it. And the technology would be they put a computer that will mask the information that is being sent to the motor. Because if the car computer senses that there's an imperfect mix according to the standards, it will pump more fuel. So what it's going to do is you have to mask or trick the computer of the car. In this case, it will be the computer of the vessel to understand that the mix is not incomplete, but it's complete. And what it's doing is that it's just, it's also combustion. You're still going to be doing combustion. It's just a different kind of fuel that you have.
It's liquid. They liquefy the hydrogen.
Yeah.
They liquefy it.
Well, at the end, when you inject it, it's going to be, a gas mixed with the bubbles that you inject. So, but yes, it's basically that. But that's not my field of work. That's more mechanical, right? More thermodynamical, and it works. But it works. Yeah, it works. So the next step of it would be to find what type of mode the engine is working on. Are you transiting? Are you using your main engine? That is, if you are in offshore operation, you're going to be using your main engine. And then that means that your emissions are going to be different. So depending on what type of mode you're using in your engine, that also means that you're going to be emitting different kinds of pollutants. For instance, when you are berthing is when you get into the harbor, and you're actually being pulled by trucks. And then that means that your emissions are going to be lower because you're not using your machines altogether. You're just using the power from the tugs, right? So maybe emissions from the tug are going to be different, but not yours. So that's why when you're using the berthing mode, emissions tend to be lower in this sense, and so on and so forth. Then we have used neural networks, regression models, gradient descent, and then we wanted to just feed to an AutoML teapot model and find out whether it was going to give us, it typically finds you the best, an optimized fine-tuned model. So that's what we wanted to do, and we tried them all. The target was NOx emissions, SOx emissions, and PMX. PMX is PM25 and PM10. Those are particulate matters. So that's a mesh measure. Whatever goes through the mesh when the mesh is 2.5 millimeters, then that means that's a PM25. If it goes through a PM10 millimeter, a 10 millimeter mesh, then that's a PM10 type of. So the mesh size actually tells you what particle is being considered at that time. SOx, in our case, we dealt with sulfur dioxide. So SO2 was our main concern of measure. And NOx is, we're measuring anything that with NO in the system. And then compare. Basically, at the end, you're going to have one that will be giving you less error metrics. And the metrics that we pursued were, we actually built a web spider diagram to find out which one was closer to the zero. And we use explained variance score, we use mean absolute error, mean square error, so several metrics to understand which one of them was going to give us the most closely. In our case, the LSTM, the XG gradient boost network was the one that gave us the best solution for NOx, and the AutoML teapot run was the one that gave us the best solution for the SO2. So it's not a one size fits all type of model. You have to actually try them and see which one of them fits better for the type of solution that you're working on. Now, the problem actually goes on the next portion of it. If you actually build a full optimization mathematical programming model on this kind of thing, remember you have 1-0 variables, and there are many of them because it's a network model. But it's a capacitated problem too. You have to decide how do you load your containers. You have to make decisions on where you split the cargo. You have to include congestion. You have to include potential weather delays. Those are the things that will, and actually, if emissions is your main concern, you also have to include things like the wind. And why the wind?
Diffusion.
Yeah. It's air quality, right?
Yeah.
So if there's a high stream of wind, then it will diffuse the pollutants, and the measure for you will be lower. If it's raining, then at the beginning of the rain, most likely we're going to sense more. But once it cleans the air, then we're going to sense less. So those variables have to be accounted for in the system. Now that makes you or forces you to have a very large mathematical problem, right? And if you are familiar with mathematical programming, then it's constraint optimization. And if you have networking variables, you have a lot of ones and zeros over there that you have to make decisions on. And so it's combinatorial in many ways. That means it's very complex to solve in a brief amount of time. To the point of our colleague, if it is a planning process, then I have time. I have enough time to work on that. But if I'm reacting, then I don't have enough time to work on that, right? So if I'm already running and I'm receiving information on the geofence that I'm building, and this is geospatial analysis that is being put together, then the problem has to be, in our case, decoupled. What we did is use large-scale methodologies. We tried vendors, and that was one of the things that we used. We also tried dancing wall decomposition. We tried column generation methods, and at the end, we decoupled the problem to make it the matrix that is generated is very sparse, so we can take advantage of that sparsity and then break the problem into main problem and then many sub-problems, and then feed the results and handshake them all together. Okay, so that was our approach. We decoupled the problem. There's an article that I have we published last year on this optimization modeling structure. But it's basically that. If you are in the port, it is basically an assignment model. Vessels to berths, quake cranes to berths, yard equipment to berths, and so on and so forth. It's an assignment model, and then it uses all operational resources. It schedules. If you are familiar with scheduling tasks, scheduling is also a combinatorial problem. So this is really a mathematical program that needs to be broken down into pieces so that we can solve it more efficiently. And time it would be a concern here. Now, from what we have done, this is the This is not ours, by the way, but this is a very neat paper that we found that actually did what we are planning to do. So it includes, so they built a full routing optimization system to reduce emissions, to mitigate emissions in the network while keeping the network efficient. And then they included everything that we're doing, trying to include all the data feeds. Of course, they did it on a data set that was controlled. I have no control of the data set. I have to force the control. That means I am receiving data feeds. I need to filter that data sets, those data sets. I need to find the main features and then put them together to handshake with the system. And then the last one is currently under review. It passed the first revision, so hopefully that's going to be a paper that it will be published. And it's an AI-based modeling applied to real-world emission estimations in maritime and intermodal networks. So this is basically our technical part of it, what we have done, and what we're planning to apply. And again, this is now a 10-month implementation. So we need to be actually quick in deploying. That's the problem with industry problems is that you have to actually deploy very fast. Okay. Now, the good thing about it is that I am not sure if you have tried this, but if you are familiar with building optimization models, now anybody has used Gurobi before? Like one of the most powerful tools in solvers in optimization. It's free for use. It is free to students and academics, so you can use it. And they have, to my knowledge, they have been the second large solver developer that have implemented large language models to automatically build mathematical models. So from this point of view, what we are doing with my students in this case, one is from computational science, the other one is from MIS, is we're using AI-powered decision support systems. In our case, we're using Wabtec, which is from a company called Hypothalamus AI, to reduce the time to deploy. And that is what it has helped us do, is taken down from 12 months to 3 months in deployment. And it's still the same mathematical model that is going to come at the end. Of course, there are caveats. You have to double check whatever is bringing. And second, you have to know what you want the model to be. Somehow, that knowledge still has to be there. So it's not an AI doing whatever it can. But there's a good point to it. It finds relationship that I was not aware of as a modeler. And I have been modeling in industry for 20 plus years. And it found relationships between the data feeds that I was not aware of. And it gave me an equation for it. So that is the interesting part of it, is that even if I don't know exactly what it's relating, at the end, it's going to tell me what's doing, and it's a mathematical model. So it's an equation or an inequality. So I am going to be able to have a sense of that relationship and then try it out. And sometimes it's been helping us to make tighter coupled models. Sometimes it's just giving us garbage. So you have to actually know what it brings you. Okay. Yes.
The open source optimization model, hearing aids, what was it called again?
So the solver is called Gurobi, Gurobi. Yeah, so Gurobi or Gurobi.
Gurobi.
Yeah, and but you can also get a handle on systems such as Ciplex or Express Solver. Those are solvers which are open for academics, so you can use it in your classes if you want. And those are the full license, so you don't have to worry about having constraint in the number of variables or the type of problems that you can run on. It's mathematical programming. So, okay. Now, what I expect to gain is a reduction in port and intermodal network emissions. And we know that for a fact because we have done it. I implemented it for the port of Cartagena in Colombia and for the port of Barranquilla in Colombia. So we know we can do that. Increase operational efficiency on the container routing through AI-driven decision making. And we have done it through mathematical modeling. What we're doing now is just enhancing that modeling stage with the use of AI. and scalable model for broader implementation across global supply chains, because our scope would be limited to the hinterland of the port and predictions to the endpoint of the container network. That's it. We're not, and from the seaside, we only take care of what's in the blue zone of the port. Okay. Now, what you see here is that I will be able at the end, and with the simulations that we run, and then with the optimizations that we run, I will be able to assign to each one of these boxes that is on a vessel specifically an eco score, as well as a total generalized cost in terms of efficiency. I am going to be able to tell the owner, the cargo beneficial owner, this is what you are emitting, this is your score in terms of eco efficiency. This is you closer to net zero emissions. This is you farther away from net zero emissions, if that's what worries you. If you don't care about that, then I'm going to tell you, well, based on the constraint, I flip the problem. I'm going to tell you, based on a constrained, environmentally oriented problem, that means I'm going to put a constraint on the emissions, then this is the profit that you're going to get for bringing your container through the use of our network model. Okay, so that's basically what we do. We have an ability to use big data now to establish more eco-friendly freight movements in the port. We have a better capacity to understand the environmental impact of certain freight movements, and we have an improved understanding of ways to reduce the carbon footprint. That's what we expect to have at the end, and this would be totally visible for the community. And that's part of the project with the GOVIS grant, is that this all has to be linked to the data interoperability highway that the state of California has implemented. So it's going to be completely visible to the community altogether. Now, call to action in this case, and I actually asked Professor Castillo to help me on this. Yes, I do have 2 students hired right now. I am the partnership part. I'm very good at doing it. So that's something that, but I am still looking for somebody who wants to partner into, you know, I'm going to have a lot of data. So if we want to have participation from the computational science side of it, students, faculty that wants to, you know, play with data, I ask you to just give me a call. I can, you know, recommend the problem, give you part of it, and yet maybe we can make decisions together on what to do. But I'm already doing through the collaborator, we're also doing the partnerships with policymakers, so I have to, yes, I had to travel to Sacramento to speak with the government to see what we can apply, what we cannot apply. We had to talk with the guys from Waterfront, which basically is a union, but it's a company. So they work as a company, but they're unionized. And then we actually to bring them aboard, otherwise this will not work. Okay. Also with the onshore unions, we have to work together. So stakeholders mean everybody that is connected to what we're doing in this case. Somebody mentioned Long Beach. I think it was Jose, right? So we need to make this available to all the ports. So that's the part of it. In California, just in California. Actually, one of the main concerns in the negotiation part of the contract was what happens when you are going to apply this outside of California. Then SDSU wants part of it, right? So this is we're going to put our soul and our knowledge into building this solution for you. So we need to be rewarded for that. The agreement at the end is we're going to give you a fixed fee at the beginning, and that's it. We're going to use it forever. And the university said yes. So there you go. I no longer have to worry about what happens in the future unless they call us back, for doing this. But from the students' side of it, what I'm looking for is people interested in working in real data problems, real life data problems. I'm looking for students that are willing to, first of all, commit to be part of a project that it's, in my opinion, very interesting for our community. But also because this is actually, implementation of techniques that could lead towards research projects from our end together. I am planning to submit grants. One of them is under consideration by the Federal Railroad Administration. We don't know what's going to happen with that because we don't know what's going to happen with federal funding anymore. But it's under consideration right now. And there's also an integration of these practices into our academia, into our classes or courses that I'm working with my students. So my call for action would be, I am willing to, work together with you to refine the models. Maybe you have some ideas that I have not tested. And then don't take me wrong. I need to deploy this in a short amount of time, but the data I will be able to work with from now on. So research-wise, this is actually a wealth of information that we can use. Thank you. Yes.
Last week. Well, for the IoT stuff.
So in our case, Port Optimizer is the one that brings all the data for me.
Yeah.
I used LabVIEW when I was dealing with continuous variables mainly, but not with discrete variables in my case. When I'm optimizing, I typically use a mathematical programming optimization. So unless it is reinforcement learning based, that's coding. But yeah, no, not for this. I haven't used it for this, so no. But I'd be willing to prove it.
Oh, it's data acquisition and stuff like that.
Yeah.
I have a question. In the beginning of your presentation, you said Hamburg has
27%
of the total pollution of that city. That means they have their own model to measure this pollution.
Yeah.
And that model, so when you are planning to do this research, their model is different. I guess it's different from what you're trying to do.
So the guy that ran that model is in my paper. So it's not different. It's similar. There's a different environment. Hamburg Port, the port of Hamburg, is actually a river port, 42 kilometers inside land, and the city of Hamburg surrounds the port. So it's a river port, and then the city is surrounding the port, which makes it a lot more complex for the city because all the pollution stays there, right? In our case, all the ports are actually bringing into the land the pollution. So the winds, or when we have Santa Ana winds, then they come into a different direction, but then the wind direction actually makes it different in terms of where the pollution has to be measured.
So the model is similar, but with different variables.
Yeah.
To build this area.
Different conditions for the measurements, and then different variables as well. You had your hand first.
Right, you get a mathematical model that tells you what exactly, like the emissions, like how much emissions you'll get given the certain inputs or something?
What type of, so there are several stages in the modeling. The first stage is predictive, which means based on all the data feeds that we're getting, we have to use those data feeds to predict a level of emission in a given time. So in a given time, in a given location, because it's geospatial. So that's the first stage. I am going to predict where the emissions are going to be before it happens, based on the sequence of vessels coming, based on the trucks that are approaching the port, based on the equipment that I'm going to be using. So that's the scenario planning part of it. But then with that information, if you want to keep that value to a minimum, that would be that value is predicted based on the usage of resources. But if you want to have an incidence in mitigating that value, then you have to change the way you use your resources. So that means that simulation forward is going to have to be led by the decisions that the mathematical programming model makes to accommodate resource usage. And resource usage would be, how do I use my birds? What equipment am I using? How do I schedule the vessels? What type of vessel am I allowing to enter the port first? That's the traffic sequence. Decisions such as what's the route that the container has to at the end have? And then that route is going to modify the measurements of emissions that you will have in real time when it comes. So there's going to be a comparison of the simulation that I do with the predictive model versus what happens with the IoT sensor in any given place on the geofence that we place.
Okay, so the mathematical model is the thing you think is simulate
The mathematical model drives the decisions that have to be made for the port.
See, what I thought you were talking about was like, okay, you have some neural network that's trying to predict based on all these features, in very broad terms. I thought you meant like, okay, that neural network is kind of a black box. It's not really, I mean, okay, you can look into it using, explainable AI, but I thought what you were saying is that, okay, that there's like a special kind of network with, you were saying a Kolmogorov-Arnold network, that neural network that predicts based on all these features is actually like an equation or something. So I always in my mind, because I'm very biased towards a symbolic regression, I thought you meant like, oh, that this neural network is like some mathematical expression that once you tune the parameters, that's actually going to tell you, oh, the emission is based on like this relationship between it's like an equation that you could write in terms of the emission.
So any of these models, even those black box models that you have, could be mapped into an equation. All of them.
So are they in practice?
So in practice, what I told you, when I want speed of reaction, I map all the values that a neural network can have, which is the black box that you're mentioning, into a decision tree, which is induced. And then I partition the space at which decisions are made. And that partition is an equation on each one of the centroids that I get. So it's basically, at the end, you're gonna have equations, right? If you wanna react rapidly, you're gonna have to map it to equations. The CAN networks is something that I'm researching on. And it's a completely different paradigm of neural networks. And it's something that it's coming up like really nice, because it's mathematics. So it will give you the equation, even if it is a neural network. You don't have to get out of it. So that the mapping that is finding is actually mapped on equations directly.
The neural network itself is an equation.
It's an equation.
Yeah, I've heard of this. There was like things like equation learner. That was, I think, one of the first instances where they had this neural network that like the activation units were like actual functions, and then the weights, like it would learn the weights, and then that the thing would actually, like the network would actually be a function. But I'm wondering if you need this not just for speed, because I imagine a huge neural network takes a while to evaluate. It has like a lot of parameters, but if it's also for the interpretability, like how do you communicate with stakeholders, which variables are important for this given scenario, or is it a combination of both?
So the part in which you do the feature engineering is actually not needed in real time. So understanding what variables are important is something that you can use based on historical data. So that doesn't actually need to be done with fast speed. What needs speed is actually when you have to react to a condition. That means when your mathematical program is telling you, your predictive model is telling you, I am predicting that you're going to go above the threshold for emissions of SO2 at this time with the conditions that you have planned for operations in the port. If that is predicted, then there's a decision to be made right there. And that decision is you have to change the operations in the port.
Sounds like a reinforcement learning thing, where you got an agent, you have to make a decision, and then it gets some kind of result, and then is it like an online learning thing where you're like
yes, it learns with historical data, but it operates on real-time data sets. So the thing is, it's not purely reinforcement learning, because you're not going to see a Bellman equation there, but instead you're going to see a mathematical program there. So it's basically an objective function telling you, or a compound metric telling you, this is what I want to minimize or maximize, based on you have to fulfill these conditions. You have to have comply with capacity constraints. You have to comply with all the resource usage complaints. And
okay, that's the mathematical model, and then what you actually do, and then that influences what the model predicts that you Yeah,
Exactly.
but you don't know that beforehand, so you have to make a decision, but then there's also the actual data, which apparently doesn't match with the model, because the model, right? So it seems like there's two things, it's like you're iterating the mathematical model and you're iterating your
Yep.
decisions.
Yep.
Okay, so yeah. That's the complicated,
It's-
you always encounter.
That's the beauty of
Anybody else?
that's the beauty of working with real life problems that you know, you never know what's going to happen until you face it.
I think you had your hand up.
Okay, so I have so many questions, but.
You can use AI and tell it resume into the 2 questions.
Sure, yeah. So you said that the XGBoost gave you the best result for NO gas.
One of the 2, SO2 or NOx.
And SO2, you said for AutoML gave you the best
Yes.
result. Do you have any explanation why they kind of reacted? Because I think the input is the same,
Mhm.
but the output for the models.
So the variable that I'm predicting is different. One is SO2, the other one is NOx, but the input bits are the same. Explanation, none whatsoever. You just get me better results, and then we use it.
Do you have a plan to kind of add explainable AI for every decision that you're gonna just make?
Not within the 8 months that I have to work on this, but yes, for the research part of it, I am very much interested in allowing you. So one of the things that we've done with Wabtec, which is the meta modeling tool that I'm deploying, is that it can write the code in either Groovy or Simplex or Express, but it can also write text directly to you to tell you this is what this equation means, this is what this equation means. So that's kind of explaining what the model is doing, but not explaining why it's doing. That's the part that I'm interested in researching, but and that's not for 8 months, that's the longer term.
Yeah.
I don't know.
Okay.
Already asked 2 questions.
You can write me an email for that.
Yeah,
Yeah,
sure.
but I asked like 8 or 9 of them.
Well,